Hey, Ben Pearson, the Roaster Tracker. I was hunting around on Reddit the other day and I found a very, very interesting question this morning that has really got me to think. That is, when did we first know that there was going to be an eclipse on this last, this week, April 8th, 2024? And that got me really, really thinking and digging into the history. I knew that there had been some work that had been done by the ancients had done this. A lot of the comments on there had supposed that like the Babylonians could have known about it if they had only bothered to calculate far that forward. And the answer is no. The Babylonians would not have known about it. But when could we actually reasonably have known about this? And when did it first appear in print? So the earliest reference I can actually find that was solidly in print is from 1887. And while I was going through the list of this, I learned an enormous amount of stuff. The 1887 actually has maps. The maps aren't super accurate. I'll post here what that map looks like. And you can see that they thought it was going to be in a different path. This is what the actual path was. And they don't quite align, but they're close enough that you really got to be impressed that they did this by hand and without a lot of the modern day knowledge that we have. So let's dive deep into the history of predicting eclipses. So that way we can understand where we may have actually come into this information. The first people to somewhat accurately predict eclipses were, I believe, either the Babylonians or the Chinese. And they both had a similar system. You could clearly see that the moon returned to the same spot roughly every 5 to 6 months. It depends a little bit just on how the planets align and whatnot. But effectively, this is called an eclipse season, and pretty much every time you go through one of these eclipse seasons, you'll either have a lunar eclipse or a solar eclipse of some kind. Now, it may be a relatively minor one, and it may be more than one, but something like that will happen. But the prediction details are a little bit harder to actually know. And there's something that's called a Saros cycle that they eventually figured out, and that is every 18 years and give or take 10 to 12 days, so we'll call it 11 days and 8 hours, then the sun, the moon, and the earth will be in approximately the same alignment and going in the same direction, the moon relative to the earth, that they were at the previous cycle. So these so-called Saros cycles are one of the interesting tidbits of eclipse history and something they had figured out pretty early. So you could predict that an eclipse would happen somewhere in the world at these regular timescales. Christopher Columbus, using this piece of knowledge, was able to accurately predict a lunar eclipse, and he actually used it to manipulate some of the natives of the Americas when he was there. Because he predicted it, he got them to go give him lots of gold because he was going to take away the moon. And then the moon returned and all was well. But, we've known that solar eclipses happen for a long time. If you stay in one spot on Earth, about every 375 years on average, there will be a solar eclipse that passes over your head. It may be cloudy, like it was for some this last April, but they have this regular cadence that they're going to show up somewhere. So people have known about them. They showed up in histories. There's been artwork that's been seen about them. And they really wanted to know how these lined up. So as they were able to figure out the cycle, this cycle works for a while. If you know about one eclipse, you can predict it forward. And there's roughly 40 of these Saros cycles that are active at any one particular point in time. And so you can predict the cycle of the eclipses as they go forward. So that being said, from the first observation of an eclipse in the Saros cycle that happened for the 2024 eclipse, they could have predicted forward where it would have occurred. And with a little bit more work, there is some work to figure out when the Saros sequence actually starts. And I think they were capable of that about the time that the Saros cycle started, but that's a more modern type of thing that they've been able to do to predict when the Saros cycle starts. And these Saros cycles happen for both the lunar and the solar eclipses. They have their own unique numbers and whatnot. So the Saros number, and each one of these sets is assigned a number, that passed in April 8th was Saros 139. So, fun fact, in about 150 years, the best eclipse that we have ever predicted, which is like a 10,000 year period of time, will happen during this just a couple hundred years from now, although it's going to pass over the ocean. So when could we actually have spotted one of these eclipses? The very first eclipse that was associated with this Saros number happened in 1501, but like all beginnings and endings of Saros sequences, it was a partial eclipse, and they all tend to be at the poles because that's just where they start. The first total eclipse was 1627, and by that point in time, it's probably getting far enough south where it may have been observed. The first total eclipse is actually a hybrid eclipse. A hybrid eclipse is one that will be an annular eclipse in part of its track and will be a full eclipse during other parts of the track. They're different than your normal eclipse, to say the least, although they have a much shorter duration of totality. But you can see the topography of the moon a little bit better. That one happened in 1627, and it did pass over Europe, so it's a pretty good chance that that particular one was noticed. I'm going to say that any competent astronomer would have been able to predict from that date that there was going to be an eclipse in 2024 on April the 8th. Assuming they had the same calendar, which is a non-trivial problem, but we're just going to assume that they, whatever calendar convergence work. That being said, it's non-trivial to know where on Earth that eclipse is going to pass over. Because of the 8-hour shift, then roughly it'll go a third of the way across the planet. But it's pretty uncertain, and in fact, it changes based off of a lot of factors. Now, in 1711, I believe it was, the astronomer Halley, who is more famously known for Halley's Comet, he was able to correctly identify and predict a total solar eclipse that was going to pass over the British Isles. His map was the first published map that looks anything vaguely like the modern types of maps that we see. And it was accurate to within about 20 miles, which is honestly pretty impressive, all things considered. They couldn't predict out the eclipses like we can today out to the distant future, but given careful observations coming weeks, they were able to have a relatively accurate map. It's about that same time that we really started to understand the shape of the Earth, and that makes a big difference as well. But, we didn't know the full shape of the Earth until the Great Trigonometric Survey, which we've talked about on this channel before. The Great Trigonometric Survey of India happened in the early 1800s, and with that we were able to know the true shape of the Earth, which is not a perfect sphere, it is an oblong spheroid, so it's a little bit shorter the distance from pole to pole than it is across the equator, and that can make a big difference when you're doing this kinds of calculations. They rely on very careful things. The 20 miles off of Halley's eclipse may have been due to that fact that they didn't take into account some of the stuff. But the truth is, these Saros cycles are a good rule of thumb. There will always be an eclipse that follows in the Saros sequence. However, the location, if that's what you really care about, varies considerably based off of just little tiny movements of the moon. And little tiny movements of the moon can be caused by all of the planets in our solar system and even other factors. It's really a non-trivial problem. So we had to take into account all of that information, but we didn't have accurate enough data in the 1800s. So back to the catalog I found, which is actually in the German language from 1887. It's named Canon der Finsternissi. I'll leave the description below. It actually went through and calculated where all of the eclipses would be for the next 300 years after, and it had happened for the past like 2,000 years. And it put them all in catalog. It showed a map showing the center lines of these eclipses. Doesn't have all of the other details. Maybe it does, actually. I don't read enough German to really know all of those details. But that clearly states that there was going to be an eclipse that would pass over North America on April the 8th, 2024. The path is a little bit different, and I'll post the image here that shows exactly what the predicted path was. It predicted that it would pass through Washington, D.C. roughly, which we'll get back to that factoid. So when I was looking through this, I first started looking through English sources because I'm an English speaker. I don't speak other languages. So one of the oldest references that I found was from 1915 in the English language. I actually found one from 1913 later. But the 1915 one had a really interesting statement that I found to be quite interesting. It talked about the purpose of eclipses. And that really comes to what we have to say. So I'm going to post it here on the screen, but just a couple of phrases from this thing that I found really particularly interesting. We are thus forced to the amazing conclusion in the future there will not be another opportunity to view a total eclipse from the sun from the continent of the United States under conditions that are really favorable and promise scientific success until the eclipses of August 21st, 2017 and April 8th, 2024. Two eclipses we have recently. Apparently, the coming generation of American astronomers will be forced to travel away from home if they wish to make observations of total eclipses. It's not impossible that before the year 2017 that astronomers of the future will have solved all of the problems connected with eclipses. So it goes on and mentions some of the things that really the 1800s, when they were able to properly identify where eclipses were going to happen, at least relatively close to the date of them, then astronomers would go out in force to try to observe these so that they could learn more and more about the sun, about things like the solar prominences. And I'm really curious what they were able to do to observe solar prominences from the surface of the Earth when the sun was not in totality. So very interesting thing. And in fact, the statements in this prove to be true. We are able to observe the sun in such a way that we don't really need eclipses like we used to. The eclipses that we're studying is really more about some very minor things. You can get a better sense of the size of the sun and a few other things like that from it. Anyways, this I found was a very interesting quote. I'll leave a link to the Google Books link where you can read the whole thing. It's a fascinating quote. I highly suggest that you look at it. So what was the next great leap forward as far as eclipse prediction happened? So two things happened in the 20th century that really made a huge difference when it came to eclipse predictions over the stuff that had come out in the 19th century and earlier. First of all, we had access to computers, first mechanical computers, and secondly, the electronic computers like you guys are all watching me on today, which had us the ability to do all of these complex calculations. And the second thing is we started to actually explore space. Exploring space had two primary things. One, we needed to know the exact position of the moon. We know the position of the moon to an extremely high precision. In the early 60s, we were able to get a pretty good position. That was actually one of the big challenges in the early space race, was to send something accurately enough to the moon that you could actually impact it. And it took both the United States and the Soviets a little while to get the aim right, because we didn't know the position. Well, one of the things that the Apollo astronauts did, and a few other missions, there were some Soviet missions and whatnot, was to leave laser retroreflectors on the surface of the moon. We know exactly where those are. And so you can find the distance using a laser beam that you shoot from a telescope to the moon, see the distance it comes back, and know exactly how far away it is. And By so doing, we know exactly where the moon is to an extraordinarily high precision. And with all of that data, you can map it out and you can predict all of the little uncertainty that's caused by all the planets, which we also better understand because of our abilities to do that. And as a result, we're able to predict the eclipses down to, a few hundred meters. The biggest uncertainty in the size of the eclipse is how big will the sun be, because the sun's size changes a little bit from time to time. But the center line is predicted to an extraordinarily high degree of precision. So really, the only thing that's uncertain is the weather forecast when it comes to eclipse prediction. All that being said, I found this absolutely fascinating. The story of how from ancient to modern times we're able to better understand the eclipses, that we've known about this eclipse to the date and the rough part of the world that was going to pass over for hundreds of years, at least for 150 years, if not longer. And the astronomers were able to plot them out and see roughly where they were going to be. And in fact, the very fact that we know where the eclipse is going to be is proof that we went to the moon, because if we did not go to the moon, we would not know the position of the moon as accurately as we do. And without that, then we could not predict the location of eclipses that accurately. So I found this all just to be absolutely fascinating, and also the scientific studying that happened of the eclipses in the past. I heard that Einstein famously had one of his proofs of the theory of general relativity by observing stars that were in the location of the sun during the total solar eclipse and seeing the deflection of the sun caused by its gravitational field of the location of the stars. But I had never really truly realized just how much they depended on this to try to study this stuff out. Thank you guys so much for joining me. Let me know whatever questions or comments you guys have. I appreciate everything you do. Until next time, keep on trekking. Take care. We will see you then. Bye-bye.